Mike Archer, owner and operator of a company called Polysciences. And in fact, this company makes specialty chemicals, and I'm very fortunate to have visited there twice. And very impressive talking about that. But let me give you a little background on how he started and what he did during his career. Mike graduated from here in Bachelor of Chemical Engineering from Purdue in 1973. He was a co-op student, and in fact, he started here as a co-op student the same year as Professor House started here on the faculty, which was in 1969. And in fact, he was an advisor for Mr. House's advisor for Mike, and then successfully shepherded him through the co-op program. I guess both learning together perhaps the things, the ropes of the co-op program. And he did the co-op with the Roman Haas company, which was a large company, and the chemical company made the most plexiglass was the most famous product. And only last year they were bought out by so it existed for a long time, perhaps actually overused. After graduating, he joined Roman Haas and he ended up his co-op program. And then he was initially in Baltimore when he was there, he went to school, and also got then a degree in accounting and became a certified public accountant. Then his next the Roman Haas was in Chicago. So of course you can just imagine after he went in initial parts, he continued with education and received degrees and credentials and capabilities in order to be able to do what he then subsequently did in So in Chicago, while he was there, he obtained University of Chicago his MBA in finance, marketing, and accounting. So he got that degree as well. In 1980, then he was transferred as sales manager for Roman Haas in New Zealand. And so he lived there, and then subsequently he was made the divisional manager in just a few years in New Zealand, and then in Mexico City, to be the divisional manager for a number of programs at Polymers, headquartered in Mexico City. And then, in 85, just 12 years subsequent to his graduation from here, he then returned back to the U.S. in Philadelphia and started working with Polysciences. Polysciences itself is celebrating, well, the school is celebrating 100 years, Polysciences is celebrating its 50 years. So Mike has been with the company for a little over half the time, half the period of its existence. And he then joined from 85 and in fact purchased the company from the owner at that time,
Thank you very much. Good clapping up there. That's good. Well, when Arvind invited me to speak, I needed a topic. And since 2011 is the 50th anniversary, and my 25th anniversary at the company, I was able to come up with a topic. So that's why we have the first 50 years of Polysciences, kind of a tongue-in-cheek sort of a topic, but it's kind of humorous that a company can be 50 years old and still be this small, but we still have a lot of time to go, I think. So I'm here to tell you the story of how Polysciences came to be and how it has survived all this time and where it's going. So the name Polysciences means many sciences, and in 1961 it was founded by a guy named Dr. David Halpern. He was a brilliant chemist, and it had been the second company that he founded. His first company he lost to outside investors. He had targeted a niche market of electron microscopy sample preparation. You can't have a more niche market than that. And he put in a whole $200 in 1961. He wasn't able to take a salary out of the company until 1975. So what he did was he started in his garage. That's why I have the picture of the garage there. He started making very high purity materials because there was not really very many sources of high purity materials in 1961. Started with osmium tetroxide and glutaraldehyde and other similar materials to prepare samples for electron microscopy operations. So he made steady progress, and because his wife actually made him move out of the garage, having dangerous chemicals around 5 children is not a good idea. And so he went through a progression of buildings, a garage, a storefront, a warehouse, the normal thing that you would expect, into a custom building. And I found this very old picture of the original drawings of one of the first buildings of Polysciences in Warrington, and was able to find that. So we're, if you're familiar with the area, we're near the Willow Grove Naval Air Station in north of Philadelphia. He had a simple sales strategy, no salespeople. He developed a catalog, put a lot of products into it that he was making, and he mailed them out. This was before faxes, before email, hard to imagine. And he was selling scientist to scientist. So it was a different market than most people approach for a company. He had a very high quality reputation and was able to survive that way. There's a picture of him. I hated to put that second line in there that he went to Notre Dame, but he did. It's a fact, and so I have to recognize that. Hi, Arvind. He did start out at MIT, and he got a free ride to MIT. So I think he was the smartest kid in Boston. Got a degree, obviously, from Notre Dame, and his first degree, I think, was in chemical engineering from MIT, and then he got a PhD in chemistry from Notre Dame. The first company he started was named Monomer Polymer, and he eventually lost that to outside investors because he needed capital and wasn't very savvy about how to control such things. And the company eventually was sold to a company called Borden Chemical Company. He was a very smart guy. They recognized that and made him the technical director. And so he moved to Philadelphia to be at the company headquarters. And then there was an event in 1961. Now about me, I grew up in southern Indiana on a little farm. That's me, the little kid, fishing in the puddle on the side of the road, but nevertheless I'm catching fish. When I graduated from Purdue, I went to work at Roman Haas, as Dr. Varma said. I eventually was able to get a CPA from the state of Maryland. I got married. My wife and I were on our honeymoon, a whole 3-day honeymoon in Bermuda. And on the second day, Roman Haas called us and said, "Mike, something's happened." We had a guy England, and he left the company. And so we're going to fill the void by moving a guy from Chicago to England, and we know you've quit the company and you're going to go to Chicago and you're going to find a job or do something to live while you're going to graduate school there, but how about this? How about we move you there? We'll pay for you to go to graduate school, and you can have this guy's job. Well, it was an easy decision, obviously, and so that was probably the most lucky thing that's happened to me. We moved to Chicago, and I got my degree in 1980, and then Roman Haas visited me and said, well, we'd like you to move to New Zealand. So I had to get out a book and figure out where New Zealand was. And when I saw it, I thought, oh my, this is going to be an adventure. But we did. We moved to New Zealand and had a great time there, learned a lot. It was very interesting to live outside of the United States because in the New Zealand society, everybody spoke English, but they didn't think like I did at all. There's only 3 million people there, 70 million sheep. Totally different kind of a society, but a great education. After 2 years, they moved us to Mexico, and we remained there for about 4 years. Very good experience. They didn't train us at all in being able to speak Spanish, so we just had to do that while we were there. And Mexico is the exact opposite of New Zealand. New Zealand was very green, and the people were just a little bit standoffish to Americans, especially because there was a situation going on during that time between the United States and the Soviet Union, and we were sort of looked upon as a dangerous society. When I went to Mexico, it was just the opposite. Everything was brown, but everybody was so friendly, it made it a wonderful place to be, and we had an absolutely lovely time in Mexico. But then, 1985, there was this giant earthquake. So 1985 was a year of change for both me and Dr. Halpern. Dr. Halpern had lost his technical director to a heart attack. Of his 5 children, he had one that was interested in coming into the company. He had also died tragically that year. For me at Roman Haas, I was in the Mexican earthquake of 1985. 640 buildings fell down. About 60,000 people were killed. I was in Guadalajara at the time, and I was in one of these Hyatt hotels that are hollow in the middle. I was like on the 7th floor. It happened at about 7:15 in the morning. I was still sleeping, and I was literally thrown out of my bed onto the floor. And this thing went on forever, and so I got up, I quickly pulled on a pair of pants to open my hotel door, room door, and looked outside. And it's an earthquake. If you've not been in one, you wouldn't think this, but it is the loudest thing you have ever heard. And so the building was going back and forth. I was on the 7th floor. I looked out my door. People were screaming. It had a glass elevator. The cables are whopping against it. And I hear somebody scream that, hang on to the center part of the building, the outside will fall away first. Well, this is just what you want to hear, of course. And but I did that, and after 2 minutes, the thing stopped. I went back into my room, quickly took a shower, got dressed, went downstairs, and nobody was there. And so I asked the hotel people, well, what happened? And he said, oh, Mr. Ott, you're the last person out of the hotel. Everybody else had left without taking a shower. So, I mean, it was a tough day because, you know, all the communications were cut off. There were no cell phones then. There was no communication with Mexico City, where my wife and our young Ryan, who graduated from here, was. He was like 4 or 5 months old at that point. So I went out to the airport, and at Roman Haas, they always taught us to carry large amounts of cash in your pocket. So I did. And I used that, and I got on the next plane that left for Mexico City, but that was 12 hours later, and not knowing what I was going to find at all when I got to Mexico City. Fortunately, when I got there, I was able to get a taxi to my house, and Ginger was not there, but she left a note that she was over at the Eli Lilly's guy's house, and I went over there and found them, and they were fine, because our house was built on the lava flow, which is in the southern part of the city. So we were very fortunate to survive that. But that's how life, if you get to be this old, you've had some fortunate things happen to you. I had a friend at Roman Haas who was talking to me at the time. Ginger and I decided that 6 years was long enough to live outside of the United States, and we decided to ask Roman Haas to move us back. They did, but there were no great opportunities in the company at that point. So a friend of mine suggested that I talk to this guy, David Halpern. He had this small company, had had some trouble, and needed somebody to manage it. So I met with him, and after several meetings, made a deal. And he said, if you come to work for the company, I'll retire in 6 months and you can run the company. So I did that, except that he didn't retire until 8 years later. So I was able to find a couple pictures of this earthquake. If you've never been in an earthquake or you've never seen the devastation, it's unbelievable. It's hard to imagine how bad it is. But Mexico City, by the way, is built on a filled-in lake. And so the wave that went through, and this went on for 2 minutes, was about a 9-foot wave in the ground. And of course, that tears a lot of buildings up pretty badly. So what was Polysciences then in 1985? This was a huge change for me from Roman Haas. From making chemicals that you sell in drums and tank wagons to chemicals that you sell in tiny little bottles. At the time we were working on, and I participated in this project to isolate Taxol for the National Cancer Institute. Polysciences was the first company to isolate Taxol on large scale. Now, what's Taxol? It's the only drug that's been found to be effective against ovarian cancer. And it came from the bark of the Pacific yew tree, Taxus brevifolia. So the NIH sent us, or NCI rather, sent us 10,000 pounds of bark. And we ground it up, soaked it in solvent, put it through large chromatography columns, 10 feet tall, a foot in diameter, concentrated all of the material that came out, and after about 6 months, we're able to deliver back 500 grams of some of the most toxic material ever been known on Earth, actually. It was a great project to work on. We developed at Polysciences a bone cement for human hip repairs. If you have a hip problem and they have to disassemble you and chop off the top of your hip and put in a mechanical one, they have to get it to stay in the bone of your leg somehow. And so we invented a material based on methyl methacrylate that is a monomeric material that you react in place after you've inserted the hip replacement into your bone. It was another fun project. We made things like foot powder for the U.S. military out of undesolenic acid that worked in difficult conditions that the military finds themselves in. And another interesting project was Elizabeth Arden, which is a cosmetic company, asked us if we could isolate a material called ceramide for them. Well, it turns out ceramide comes from pig hair, so I had to go find a place that I could get pig hair from, which would be a place was a slaughterhouse. So I went there, I got a couple 100 pounds of this pig hair, we brought it back, ground it up, soaked it in solvent, put it through the chromatography columns again, and came out with 500 grams of ceramide, which we sold for several $100,000 to ceramide, or to Elizabeth Arden, that is. So a totally different kind of project-oriented but interesting chemical materials we were involved in. We developed a hematology stain, which is a blood stain, for automatic stainers for a company. We developed a UV light absorber for retinal protection that goes into intraocular lenses. If you have the misfortune of developing a cataract in your eye, the surgeon has to take out your natural lens and insert a synthetic one made out of a polymeric material. And so we became very much involved in making these raw materials to make the intraocular lenses. And we developed a paraffin for histology that could be sliced as thin as 4 microns for embedding human samples for laboratory analysis in the hospital laboratory. So a lot of different kinds of things, quite varied. So in 1993, the 8 years later, I finally was able to make the deal. So as far as Mike and Ginger were involved, we were all in. If you've got kids and you're going to school and you've made your payments, and you have to have a house, you have to have a car, it's really hard to save money. So we had a little bit of money, but to buy a company, you need a large amount of money. So you have to borrow, or in my case, I had to borrow a very large amount of money from Core States Bank. At the time, it was about $4 million, which is, as they say, real money in those days. The Bucks County Industrial Development Corporation, which is a local authority that helps companies stay there because this company could have been sold and moved away, helped, and I had a small outside investor. But it was one of these situations where it was either going to work great or I was going to be living on the side of the road with my wife and 2 kids in a tent someplace. So, be careful what you wish for, because then there's the day after. I was successful in buying the company, and you wake up the next day and you say, now what? So I had 60 people totally dependent upon me for their living, and I had to decide what to do. So I used basic chemical engineering technique. I broke down a big problem into little ones and then added them all back together and came up with a solution. So I broke it into various little parts, assigned it to certain managers, and was able to organize the company so that it could focus on the individual markets that we addressed. We actually started doing some marketing. Before then, we just sort of depended on people finding us. And right then was about when the internet was starting. It's hard to imagine, isn't it? So we were very quickly had an internet website, and that helped us tremendously. So that was 1993, so here's where we are now. We have quite a few different divisions. We're into biosciences, as we call it now, electronic materials, monomers and polymers, microspheres and particles, which a lot of you are interested in. Custom synthesis of materials is our biggest single market. Believe it or not, we make personal care products. I have a product line called Dionis that's sold in every Cracker Barrel in the United States. There's 600 of those. And we do industrial packaging for other companies because we're regulated by everybody who's got a badge, that is the FDA and everybody else. So we make a lot of materials for people who need to have them made in a regulated environment. So I had to get control of the company, and I had to keep control of the company. So I invented what I call a daily report, a financial report. And on this report, I get information about how much money came in. You know, the most important thing in running a small company, or any company, is cash flow. I watched every dollar that came in every day from every location. I still do, every day. I know how much money is going out and the payments that we make every day. I know what the sales are in every location by category every day. I know what our balances are in the bank. I know what our accounts receivable are, aged 30, 60, and 90 days, and accounts payable the same way. And if you're not doing that, you're not in control of your company, and you're going to get surprised in a negative sort of way. The other thing I started to do was get the very best people that I could. The way that Dr. Halpern operated the business was, in many cases, we got by with what we could find, or people who would work for less. And so the smartest guy that I knew in Roman Haas was a guy named Dr. David Templer. And so I immediately set about to hire this guy away from Roman Haas. It took me 18 months, but I was able to do it, and that helped us tremendously. In an operating style, you have to pick a style. What are you going to do? What are you not going to do? And I decided there's no way I could ever compete with a commodity-oriented company that competed on price. And so special materials only, totally gross profit oriented. I call that the Roman Haas polymers, resins, and monomers style. And that's worked very well for me, worked very well for Roman Haas too. And this is the report I designed. Reports, nobody likes to read reports that are 18 pages long. This is one page. And so here, you can't read it, of course, but I have all these different sections I just talked about. And so every one of these numbers has a meaning and an importance. And that's one way to keep control of the way to keep, for me, to keep control of the company. So what happened? So the company was formed in 1961. 86 is when I showed up, a whole $5 million in sales. 93, when I bought it, 6.6 million. By 2000, because I was working off a huge debt load in between 93 and 2000, we were only at 10 million. And that gave us a compound growth rate from 86 to 2000 of 4.5%, which is okay, but we were making a living. It was fine. Then, once I got the debt level down, I was able to start making acquisitions. And so I started buying small product lines and small companies that would fit into the company. Biomag was an acquisition that enabled me to get patents that I needed in the magnetic particle arena to be able to operate in there. I bought Bangs Laboratories. That's the company that was in Indianapolis from Dr. Bangs. I was able to buy the Kulik and Sofa electronics chemicals business, which is epoxy-based monomeric systems that are used to in making electronic chips. So we were in the electronics chemicals business at that point. I bought Dream Cosmetics, which made lip care products, and Dionis, which makes the skin care products that I just talked about that are in Cracker Barrel. I was trying to stay diversified. You say, well, why didn't you just focus on one thing? Well, it's very dangerous in a small company to focus on one thing, because that one thing could either all of a sudden go out of favor, or you can have one large customer who can decide, I'm not going to do business with you anymore, or some negative thing can happen when things are concentrated. So I've always focused on keeping things as diversified as possible, not letting one customer, one product line, one product comprising more than 5 or 6% of the company. I continued on this line of hiring excellent employees. And so I was fortunate in some respects to have been in a large metropolitan area like Philadelphia, because the large companies were always consolidating and cutting back. And I was able to pick up very experienced people who were grateful for employment and were glad to get out of the political activity of a public company and come into a small private company and be very much recognized for their performance and their contributions. So these are some of the companies that we've gotten people from that are just fabulous, and it's been a key to our success. So, after I got the debt paid down, I was able to grow at a faster rate. And so here we are now in 2011, and we've grown since 2000 at a compounded growth rate of 10.5%, a better number, certainly. And in 2010, actually, compared to 2009, we grew about 22%, actually, in 2010. In the first quarter of 2011, we've grown, compared to the first quarter of 2010, 24%. So things are accelerating nicely. So what's Polysciences today? At our corporate headquarters and main manufacturing facilities are comprised of 3 buildings on 16 acres, 172,000 square feet. And we have 3 facilities in Warrington, very close together. I started Polysciences Europe in 1994, and we still have a facility there so that we can provide technical service in the same time zone in Europe. Our people there manage the distributors that we have throughout the rest of Europe and sell directly into Germany. It's been a very good strategy for us. And then we have Bangs Laboratories and Fishers. We just last year expanded this, doubled the size of this facility, and this is the new facility now. And actually we're doubling the size of our office in Pennsylvania this year also. So what does Polysciences do now? What's important to us? Microspheres and particles are 20% of the sales of the company. We have more than 400 different kinds. Some of these are of interest to you, and in my conversations today, I've learned of some of the interests that you have, and I'll be sending you some materials that you can study. We make, that slide before was supposed to show something that it didn't, but those were superparamagnetic particles. And what you do is you take these particles and you attach an antibody to them and expose them to a biological fluid, and then they can attach to an antigen, form a complex. You then put that tube against a magnet and it pulls the complex against the magnet. You can use a pipette, remove the other material, put back in saline solution, and resuspend the particles, and then study the cells that you just fished out. Another method, oh, there it went back. One of the other applications, of many applications for particles, is cells will eat these particles, and so you can attach DNA sequence that you want to get into the cell. The cell will eat it. If you make a put a fluorescent dye on the particle, you can now see the particle inside the cell. And so this is a lot of research is done to carry various materials inside of cells on particles. We make a wide range of particles, going from about 40 nanometers to 175 microns. And these are all monodispersed, which means they're all the same size. We can control the particle size very well, and we can control the surface chemistries very well. And so there's many, many applications that we've discussed today with several of you. In the histology materials, we make 35 different embedding kits, actually. These are polymeric systems usually, or monomeric that you polymerize. And you can make a permanent embedment then of a piece of tissue and study it over a long period of time, archive it. Many materials you have to preserve in such a way that you preserve the antigens, which means you have to be preserved in such a way that you don't destroy them with heat. So we've got systems that will polymerize at 0 degrees centigrade even. And it's a very interesting area for research. And we make we make a few diagnostic kits actually also. This is one example of one of the materials that we use. Glutaraldehyde is used to fix tissue, that is, stop it from rotting, so that you can study it. And we distill glutaraldehyde and take out this extra contaminant here, so that we sell pure material, so that no artifacts are left in the sample. Here's an example of some of the fluorescent products that we make. This TB fluor stain kit and the fungi fluor stain kits are very direct stain oriented kits, and some of the things that, I mean, one of the first projects I worked on when I got to Polysciences was register this with the FDA, which was a really great experience to figure out the labyrinth of paperwork that's required to register a product with the FDA. We make all sorts of monomers. We have over 200 in the catalog now. These aren't things that are sold in tank wagons, so we don't sell them in cents per pound range. These are more like $1,000 a kilo range. But they're very pure materials, and we can make them according to just exactly the way that you want them for your particular application. Same thing for polymers, many different polymers that are used in particularly medical devices. And I offer several hundred of them in the catalog, and the idea is to attract people to want to make a custom material for them. This is an interesting monomeric material that we make that's an epoxy. We ship it to customers, for instance in China, at minus 40 degrees centigrade in hypodermic syringes. It's released onto the chip. These are all individual wires that are welded into the electronic device from this and attached to this chip. And so our monomeric solution is put around like this. We hit it with UV light. It polymerizes in place, and it keeps the wires from touching each other. Personal care division, these are the materials that are sold through Cracker Barrel. A nice diversification for us and kind of a fun business because it gets us into consumer products. So today, what kind of projects are we working on? We have a lot of special bulk projects. I was talking today with a couple of the professors about a polymer that we're working on for the U.S. Navy. It has to do with anti-terrorism activities. We're working on coatings for catheters. You want those to be as slippery as possible. In case you don't understand that, it's very important. We make polymers that are used in heart stents to elute drugs off of them. We make very special monomers for intraocular lenses, contact lenses. We're working with the largest contact lens manufacturers in the world on that. One of the stranger projects we've ever gotten involved in was a company that wanted to ship oil from point A to point B, and they wanted to make sure that it actually got there and not somebody else's oil. And so they asked us for $10,000 worth of poly beads that were fluorescently marked so that they could pour it into the hold of the tank and be able to identify their particles or their oil when it got to its destination. We made the particles that were used for the Human Genome Project, and that went on for a very long time. And then we make these electronic materials. So what am I doing now? Focusing on the Pacific and European regions for expansion this year. We have ISO 9000 certification, but we're getting ISO 13485, which is another level that's required especially for international customers. I'm adding 4 new labs for our offices, our facility in Warrington. And right now we're so fortunate to have 43 funded development projects from other companies that we're working on, trying to invent something to solve their problems. And we're almost doubling the size of our offices in Warrington because I can't fit any more people in there. Next year, and after that, what am I going to do? I'm going to try to stay entrepreneurial in the company, react to opportunities, not make a plan and say, okay, we're 30 million this year, we're going to be 33 next year, we're going to be 37 next year, but rather just respond to the opportunities as they're presented and try to act in a logical way in growing the company. I'm not going to sell the company. One of the worst, well, for me, probably would be one of the worst things I could do because you might think it would be attractive to have a big pile of money in the bank, but what can happen when you have that is that you lose that big pile of money in the bank by doing something stupid. It's much better to have a company that is continually renewing. It's like a goose that's continuing to lay golden eggs. And I'd much rather have something to do every day and feel responsible about than to have a pile of money in the bank. My sons are both very interested in the business. I'm very fortunate in that regard. And as long as I can hang on to my chair, I'll keep it, but they'll probably throw me out of there pretty soon. And then I'm going to focus on medical applications because commodities are a very difficult area to make money in. We're going to focus on specialty materials where we can really provide value added and continue to grow as the population grows around the world. And this slide was made before I established our office in Taiwan last week, so I just listed the United States and Europe, but we now have our office in Taiwan started also. So that's it. If anybody's still awake out there, I'll be happy to answer any questions.
So you're celebrating, of course, the Centennial School. those sites, there are actually 17 companies that are sponsoring us in Centennial, so to speak. And Polysciences is one of them. They are the highest level sponsors, and we're grateful that they're sponsoring us in Centennial. Number two, so as you may recall from the earlier conversation at the beginning, that there are three categories of Centennial speakers. Those alumni who went to all the alumni, of course, focus on alumni. Those who went to academia, those who went to industry, and the third category is those who became entrepreneurs or went to other areas such as President Hannibal and medical doctors. So clearly, as you can easily imagine, Mike Art fits in the entrepreneurial category. So he's one of the entrepreneurial speakers. You can easily see the reason why. All right, so now this open up to questions.
So there's a specialty company that deals with everyone from the government to universities. I imagine you get a large gradient in the quantity of orders. Some people want the 10,000 to be, but other people want much smaller quantities. But that comes different equipment size. I was just wondering if you could comment on what sort of strategy you guys use in designing how you scale up production stuff.
Well, we don't have any large-scale equipment. The largest reactor we have is 100 gallons, and we use that to purify acrylamide. This is a very much high customer service-oriented business, and so for the 3,000 products that we have in the catalog, we have to have inventory because scientists, for some reason, don't plan ahead, and they call in the afternoon before they're going to do the experiment and want the material tomorrow. And we're happy to accommodate them. And so we have inventory of everything pretty much in stock. As far as equipment goes, since these are, I joke when I first came to Polysciences, for the same price that I used to sell a 5,000-gallon tank wagon of acrylic emulsion to a customer who would make paint out of it, I sold to Abbott Laboratories a 1-liter bottle of 2% solids of microparticles that they're making a diagnostic test out of. So this is very high value-added materials, a lot of hand-holding involved in manufacturing them, and most things are made in 3-liter flasks and highly purified by hand by very experienced chemists. So we don't have any scale-up problems, although there are some scale-up issues when you go from, say, 200 grams to 5 liters to 10 liters. It's mostly heat transfer problems. And since I have a lot of chemists and just a few engineers, the engineers have to solve the problems, obviously. Yeah. Well, the most expensive material is stuff we call blue blocker. It's sold to a company that makes intraocular lenses. And what you want to do is stop UV light from going through the synthetic lens so it won't hit the retina and the eye once it's been put in. And that material, you don't need very much of it to accomplish that in the lens. And we sell it for about $500,000 a gram. You don't want to sneeze or spill it when you're putting it in the bottle.
Questions?
You see that the company is growing right now. How do you plan to stay entrepreneurial? Because big companies respond really slowly and
Well, I think we're still very small. $30 million in sales is still a very small company. I have been very much trying to train the next layer of managers and the next layer after that, actually. And so I've got 6 vice presidents, all people that I trust very much, and they know the way that I've operated all this time. Because I've been at the company forever, 25 years is a long time. So I think the way is to teach them how to make decisions and to get them to make decisions. You know, people won't take a risk unless they feel safe to do it. And the other thing I always tell people is, if you're not making mistakes, you're not doing anything. Because if you're not making mistakes, literally you're not doing anything. So you have to be able to accept somebody making a wrong decision. It might be a logical decision, but it's still wrong. You lose money doing it. You do it all the time if you're honest with yourself when you're running a company. But it's like playing baseball, you know. Who would think you could make $10 million a year and hitting 1/3 of the time, getting a hit 1/3 of the time that you go to the bat, you know, to bat for baseball. But that's the way that it is. And so I'm just trying to transmit from me to them the risk-taking profile. And it's just a willingness to, you know, obviously it's a ridiculous risk that I took when I bought the company. I mean, I put in like $60,000 and borrowed $4 million. I mean, the amount of money was staggering. But, you know, it all turned out very well. And it's not always logical things that happen. But actually, it was a very coldly calculated move. I had studied this problem for years, actually, and I knew it was going to work. And it was because I was adequately trained. Number one, if I may talk for a minute about chemical engineering.
Yeah, of course.
I'm very prejudiced against anybody who, well, I'm very prejudiced in a positive direction for chemical engineers. And this is why, is because they've been taught how to think. I was remembering today when I was talking to some of the professors and some of the students about how when I graduated from Purdue, I was not happy. I was actually pretty angry because I thought that this hurdle course that I had just gone through was unrealistic. I didn't think that my professors cared if I lived or died, and probably sort of preferred if I died at the time. This is the way I sort of thought about it. But I did make it through, and Professor House actually was the most encouraging person here for me. And I was mad for several years until I finally realized that, well, I was pretty well prepared to compete against all these other guys who, and ladies who were at these companies, or at Roman Haas. And I started to eventually realize that my preparation that I had had was really pretty wonderful. Because when I went to school in accounting, it was like, golly, you can graduate and not work any more than this. And all the courses were just ridiculously easy for me. And when I went to business school at the University of Chicago, which is now ranked the #1 business school in the United States, it was easy to make straight A's there. And you know, it was impossible when I was going to school. I mean, you know, when the high grade on a test is 31, it does something to you. So I gradually came to a realization of what had happened to me, and that was, first of all, I was humbled, and so I wasn't an arrogant person, and have been able to stay in that mode, but I was very much prepared to compete in the world, and it's enabled me to just keep going. So I highly encourage you to continue ahead on the path that you're on. What I also tell young people all the time who are not in college yet, but are considering what to study in school, I always tell them to study chemical engineering. Why? Well, it's the one thing that you can go to school and study and not limit yourself afterwards. If you can study electrical engineering, you're totally limited. You know, you can only do that stuff. Mechanical, you can't do anything chemical. If you go to study literally anything. So I think it's the one thing you can go to school, learn how to think, go through the grist mill of going to this doing this very difficult thing, but yet you're totally open to what you can do with the rest of your life. I mean, there are people here who've gone to medical school afterwards. They weren't limited in any respect whatsoever. So I'm very high on chemical engineering, and I encourage you to continue on the path that you're on. Sure.
When in-house expertise does not fit a certain kind of customer requests, do you hire people or you pass that up?
that's where the experienced people come in that have been able to hire, because this is where the company really excels. A customer will call up and they have a problem, and so we'll talk to them about it, but the person talking to them about it is a man who's 50 years old plus, who's got a PhD in either engineering or chemistry, and who has had experience that he can apply to their problem. And so there are very few places anywhere that you can call and get that sort of experience and talk to the guy. And it's not, 18 clicks. It's, okay, the next person, you can talk to them within a couple of hours if they're doing something else. So that level of customer service is what truly makes Polysciences different than a lot of other companies. And it's been a great advantage for us.
Where do you see the company heading in, say, 10 years from now?
10 years. Well, I think that we will continue to expand. I think that the business in Taiwan will expand in the Asian countries around it, and literally that could be the largest part of the company there. I think that we'll have operating facilities in Asia and Europe, manufacturing facilities then. And in 10 years, the company's sales should be over $200 million. Should be. We should be able to provide, shoes and food for the next few years, I think, as we say.
Because the plans will next 10 years almost each quarter. As you saw him speak during the talk, that 20% growth in 1 year, and continuing that year after year, you can easily see how you can get to the scale of that very quickly. It's compounding over here. Any other questions at this stage? If not, let's thank my part.
Thank you, Arvind. Thank you very much.